In the previous tutorial, we saw the single table inheritance strategy provided by Hibernate, and we learned that that's the default strategy that Hibernate goes for if you do not specify any inheritance configuration. In this tutorial, we're going to look at another type of inheritance strategy that we can configure, and this strategy is called the table per class strategy. So what we're going to do is we're going to have a separate table for each of the classes that we need to persist. So here a vehicle is going to be a separate table, a two-wheeler is going to be a separate table, and a four-wheeler is going to be a separate table. It is not as straightforward as it seems. There are a few things that we need to consider. So let's try to implement this. Let me remove this discriminator column. We don't need the discriminator column if we are implementing a table per class strategy. The whole reason why the discriminator column existed in the single table strategy is because all the objects of three different classes were being dumped into the same table. So if three different objects are in the same table, we need a way to isolate different objects. Say, for example, I need to get only the two-wheeler objects from the table. What would I do? I would just use the discriminator column to differentiate the two-wheeler objects from the other objects. So what I would do is, if I have a discriminator value as bike for two-wheeler objects, so I would say select everything from this vehicle table where the discriminator column vehicle type equals bike. So that's the way in which I can pull up the data for the particular class that I have in mind. And that's the reason why the discriminator column was there, in order to identify your records which are there because of a particular object or a particular class. Now, if I have separate tables for each of these classes, I would no longer need the discriminator because it's fairly straightforward. If I need a two-wheeler object, I would go to the two-wheeler table. If I need a four-wheeler object, I'd go to the four-wheeler table. So there's no need for a discriminator if we have a table per class strategy. So let's change this inheritance type to a table per class strategy. Okay, so this is all that's needed actually. Let me remove the discriminator from these two entities as well. And save. Let me save this parent class as well. Now this is all that's required. Again, Hibernate does a lot of things. It does a lot of default actions. We don't have to configure each and everything. So let's run this and see what's happening. So again, what we have done is we have marked the parent class as an entity, and we have defined the inheritance strategy as table per class. And then of course we have marked the child classes also as entities. So both of these have been marked as entities. Now in my main method, I have a vehicle object, I have a two-wheeler object, and I have a four-wheeler object, and I'm saving all the three of them. Now let's see how Hibernate persists it this time with a table per class strategy. So let's run this. So here you can see it is inserting three records here. One is it's doing an insert to vehicle, it's doing an insert to two-wheeler, and it's doing an insert into four-wheeler. Let's query the database and see how the tables look like. Now in the vehicle, it just has the vehicle ID and the vehicle name, which is simple enough. We have we only have these two properties for the vehicle class. So you have the vehicle ID and you have the vehicle name. So it's saving only those values because our vehicle object that we have created has just the ID and the name. So it's saving only those two values. Now let's try querying the other table here. Two-wheeler. Again, it's the name of the class itself. So let's try querying the two-wheeler table. Okay, so here we have the vehicle ID, the vehicle name, and the steering handle. Note that the two-wheeler class has only the steering handle declared in the class. The ID and the name are things that it gets due to its inheritance. Now see, here we have the ID and the name, And here we have a generated value for the ID. So not only does the two-wheeler class inherit the ID and the name properties, it also inherits this generated value annotation. It's almost as if you have the ID and the name properties here, and you also have the generated value annotation here. So Hibernate has generated the ID. It has the vehicle ID and the vehicle names. It's generated this ID as well, and the property of the class, the steering handle, has also been added. So the two-wheeler has these three columns. Now let's have a look at the four-wheeler. It's again similar. Even this inherits the ID and the name, and of course it also inherits the generated value annotation. So Hibernate is generating the key for this class as well, and then it has the property of the class itself. So the points here to note are this. First of all, it's having a separate table for each of the classes. So no matter how many inheritance levels are there, each class has its own table. Secondly, the parent class's properties are inherited, and they form separate columns even in the child tables. So since it's inheriting the properties, and since it might have values in those properties, what Hibernate does is it creates columns for the parent member variables as well in the child tables. The third thing is the annotation for the ID. See, here we have a vehicle ID and we are marking it as a generated value. So this generated value of the parent class is also inherited to the child classes. So even the child classes will have an ID which is generated by Hibernate, and those IDs are being populated in the tables as well. So the advantage of this method is that you don't need a discriminator to identify what type of object it is. A two-wheeler table has only two-wheeler objects, and a four-wheeler table has only four-wheeler objects. So it's easier to identify what is the source of the data, what object it came from. And the second thing is it is in a normalized form. You don't have extra columns which do not have data. Say in the single table strategy, I have I have inherited the vehicle class into a two-wheeler and a four-wheeler, say, but I only have two objects in the two-wheeler and four-wheeler class, and all my objects are from the vehicle class. In that case, you have two columns that are null for most of the records in the table. So this is actually not very efficient when it comes to database design, and it is not in a normalized format. So this is avoided if you have the separate table per class strategy. So each table has from a different class. Each inherited class has its own table, and you don't have any records where the columns have null values just because it's not applicable to that particular class. Every table has only the properties that it needs, and it does not inherit any blank columns because some other child has implemented some other columns. So that way it's more efficient when it comes to it's a more elegant way of designing tables, and this is something that you would normally do if you were designing tables for these objects where you're not using Hibernate. This is how you would do it. You would normally not do the single table strategy if you are not using Hibernate, because it's not really very efficient. But the single table strategy is a default, and the table per class is something that you can implement if you want this kind of a design. So in the next tutorial, we're going to look at the third way in which we can implement inheritance.